This is a presentation of how to configure OSPF version 3 for IP version 6, and it's a part of my advanced networking course. So if we look at it, it's many similarities between OSPF version 2 and OSPF version 3 for IP version 6. It still uses the three different tables, the neighbor table, the topology table, and the routing table. And it exchanges information between the different routers in the network. If you look at the similarities, well, it still is a link state protocol. It uses the shortest path first algorithm to find the shortest path between the different networks. The metric is still the cost. It has we can set it up with different areas if you like. Package types are the same, the neighboring discovery are the same, the election of DR and BDR and multi-access networks are the same, and the router ID is still a 32-bit router ID, which is the same or has similarities to the IP version 4 addresses. If you look at the differences, well, of course, it advertises the IP version 6 networks and the prefixes instead of the IP version 4 networks. It uses the link local address of IP version 6. The destination addresses could be either a link local or a global or a multicast address. We do not use the network command when it's IP or when it's OSPF version 3. We set IP version 6 OSPF process ID, area ID on the different interfaces that we want to be a part of our OSPF setup. Another thing that is important is to remember to enable unicast routing with the IP version 6 unicast routing command when we want to use it for IP version 6. We could set up authentication, and in OSPF version 3 we are using the IP version 6 authentication instead of the MD5 or plain text if we don't do anything on OSPF version 2. So how do we configure it? Well, we do first of all remember IP version 6 unicast routing. Then here we have just set up with the IP addresses on our three different interfaces here. That's just basic setting up the interface addresses. It's important to remember when we are talking about IP version 6 that we have something called the link local address. This is only significant on the local link, and we might as well have the same link local address on all our interfaces because they will never be advertised out, but we can use them to send information out to our local link when we have this address. By default, if you don't do anything, it will automatically be set up with a link local address, and it will be calculated from the FE080/10 prefix, and then it's using the local MAC address. This is what is called the EUI64, is that it takes the MAC address, which is a 48-bit address, and put that into the host part of the IP version 6 address, which is 64-bit, and then it puts in 7 extra bits in the middle, and then or 8, and then it's flipping the 7-bit because then we will have a unique number on our interface. So it will be given to us if we don't do it. The easiest way is just to configure it like here with the /link local, and then we have the same link local address because then it's easier to remember that this is our link local address. This is just to remember the IP version 6 setup. The router ID, as I said, will be still like a 32-bit number, and if we don't configure it manually, well, then it will look if there are any IP version 4 address that's set up on our loopback addresses or on our interfaces. If we don't have any IP version 4, since this is a 32-bit number, it cannot be generated automatically. So then it will display a message saying that we need to set it manually. So it's good past practice to, when we are using OSPF version 3, to set the router ID manually. So then we go to IP version 6 router OSPF10. Still here, the process ID. Then we set the router ID. We could set the autocast reference bandwidth to 1000, for instance. So it will divide every bandwidth with 1000 instead. So then we will be able to see the difference between fast Ethernet and gigabit and 10 gigabit Ethernet. Then again, it will remind us that we need to do it all across the routers that are connected in the same OSPF domain. Yeah. Then what we do, instead of using the network command, we go to each and every one of our interfaces that we want to participate in the OSPF domain, and we give the command IP version 6 OSPF 10. Then again, same process ID and area 10, same area on all our routers. The process ID could be different, but why make it different, more difficult for ourselves? Why not just set it to the same? So on all of my interfaces, I do that, and then I actually have everything configured. Then I can use the command show IPv6 route OSPF, and then I will be able to see which networks that I'm connected to. Of course, the IP version 6 networks, and we can see the cost over here as we can in IP version 4. And that's it. So the basics here is that you do not use the network command. You set the OSPF command on each and every interface you want to participate in your OSPF domain.